Here a graph is given and we need to find the number of cut edges. So what is cut edge? A cut edge is an edge deletion upon which disconnects the graph into two or more components. We can also call it as bridge. So cut edge or bridge is nothing but an edge deletion upon which disconnects the graph into two or more components. Disconnects the graph into two or more components. So here we have to find the number of cut edges for this graph. If we observe the given graph, if we remove AB edge from this graph, then this graph will be disconnected into two parts. So AB is one cut edge. The two parts will be this one part, and isolated vertex A will be another part. Same is the case with edge GH. If we remove GH, then graph will become two parts. It will be disconnected into two parts. So GH is also one cut edge. If we check with other edges, if we remove BC, then the graph would be connected. Even if we remove BC, graph would be connected. Means each and every vertices would be connected. So BC is not cut edge. CD also same. Even if we remove CD, then the graph would be connected. So same with FB. So FB is also not a cut edge. EF. All the remaining edges will not be cut edges. So here there are only two cut edges. They are AB and GH. So cut edges for this graph are AB and GH. So the number of cut edges is 2, which is option B. We have to find the number of injective functions from a set of 5 elements to a set of 7 elements, and 4 options are given. We need to choose the correct option. So what is an injective function? Injective function and one-to-one function both are same. So first we need to know what is an injective function. In one-to-one function, every element of the range of the function corresponds to exactly one element of the domain. So one-to-one or injective function. So in this function, every element of the range of the function corresponds to exactly one value of the one element of the domain. One element of the domain. So here we have to find number of one-to-one functions. So number of one-to-one functions from a set of m elements to set of n elements would be, from set of m elements to set of n elements would be npm. So number of injective or one-to-one functions, one-to-one functions from a set of m elements to a set of n elements would be npm. Here n is equal to 7, m is equal to 5. So required number of functions is equal required number of functions, one-to-one functions is equal to npm. npm is equal to 7p5. So 7p5 is nothing but 7 factorial by 7 minus 5 factorial. This is equal to 7 factorial by 2 factorial, which is option C. A set with 6 elements is given and we have to find the number of relations which are both asymmetric as well as reflexive. Here the given relation is recursive. Why? Because the relation is from set A to itself. So what is, first of all we have to know what is reflexive relation and what is asymmetric relation. If R is a relation from A to A, that is, if R is a relation on A, then what is reflexive relation? What is reflexive relation? Reflexive relation. For all x belongs to A, then x relates to x should belongs to the relation. That means all the diagonal elements should be present. For example, if A is set with 1, 2, 3, 4, then if R is reflexive, then R should contain 1 to 1, 2, 2, 2, 2, 3, 3, 4, 4. Minimum means R should contain at least these values. These values are must and should in the reflexive relation. Then we need to know what is asymmetric relation. Asymmetric relation. For all x comma y belongs to A, if x comma y belongs to R, then y comma x should not belongs to R. This is called asymmetric relation. If x comma y belongs to R, then y comma x should not belongs to the relation. Hence diagonal elements should not be present according to the condition of asymmetric relation. That means R should not contain y. In asymmetric relation, these diagonal elements are not allowed. Why? Because if these elements are allowed, then this condition would be violated. So if we observe reflexive and asymmetric relations, then these two conditions would be mutually exclusive. That means according to reflexive relation, all the diagonal elements should be present, and according to asymmetric relation, all the diagonal elements are not allowed. Hence the number of relations which are both asymmetric as well as reflexive are 0, which is option A. It is given that ABCD is a non-singular matrix of order n by n. That means we can find inverse for the matrix ABCD, and ABC is given as D inverse. We have to find what is B inverse. So ABC is given as D inverse. From this equation, if we can find B, later on we can find the value of B inverse. So if we multiply with A inverse on both sides, then we'll be getting A inverse into A, BC is equal to A inverse into D inverse. So A inverse into A is nothing but identity matrix I. So I into BC is equal to A inverse into D inverse. I into any matrix would be that matrix. That means A into I into BC is equal to BC. BC is equal to A inverse into D inverse. And if we multiply C inverse on both sides, we'll be getting as B into C inverse. We'll be getting A inverse D inverse into C inverse. So C into C inverse is nothing but I. So B into I is nothing but B. So B will be A inverse D inverse C inverse. So we got value of B, but we want B inverse. So from this, B inverse would be A inverse D inverse C inverse whole inverse, which is nothing but C D A, which is option B.